The climate crisis, pollution, droughts, pandemics, poverty, inequality, loss of biodiversity. The 21st century has plenty of challenges for humanity. We have always overcome challenges thanks to our capacity for innovation. The knowledge we have today has been transmitted from generation to generation. That is, culture, including science. This evolution has never been the fruit of a single person, but the result of a collective effort. We are not the strongest or fastest species, but the one who has learned to collaborate and think together to solve complex problems. We need more knowledge, and to produce it, we need more science. Science done where? By whom? In following which interests? A recent global study shows that 90% of new scientific knowledge is produced in developed countries, and less than 40% is dedicated to solving problems enshrined in the UN Sustainable Development Goals, such as hunger, lack of clean water, or affordable energy. We face a dilemma. The majority of scientific outputs are not directed towards the most urgent challenges, and those seeking to use science to address these challenges face barriers. We need to democratize science. Scientific research requires increasingly complex tools, like microscopes, chemical reagents, environmental monitors, drones, computers, and many other precision instruments. They are often expensive and hard to find and maintain. With this in mind, a growing global movement is working to open up scientific equipment, that is, to share the knowledge already created. Open hardware is based on the same principles as open software. Open licenses allowing everyone to use, study, modify, and share designs, aiming to make the tools they need at a lower cost. Simplifying access to scientific instruments enables more people to participate in science and thus produce more diverse and useful knowledge. It also facilitates science education in a virtuous circle. To this end, the global open science hardware movement promotes the open publication of designs with complete documentation, along with support materials such as tutorials. Forums, workshops, and face-to-face meetings also help ease the learning process of assembling the tools. Low-cost electronic components in 3D printing accelerate the multiplication of open hardware. Easy-to-assemble DIY tools are very useful in emergencies or in places where the latest technology is not available. In addition, open instruments are more flexible than proprietary products, and thus allow communities to empower themselves and carry out their own research. They open up the agenda of knowledge production. Times of crisis call for greater and more diverse participation, collective knowledge, and technological sovereignty. A project for every problem, a tool for every research team. Open your toolkit and join the global open science hardware community.